My name is Alex Trigoub and I'm a product line manager for SWaP-C's switches and I/O boards at iTech. My presentation today will focus on a topic which is extremely important for our industry at this day and age, SWaP-C optimization. In this presentation, I will cover the following. What is SWaP-C optimization and why is it important for the future of the defense industry? What are the main approaches to SWaP-C optimization and how are they implemented in the iTech product portfolio? How can the basic SWaP-C capabilities be extended through various integrated hardware and software add-ons to create a real multifunctional product rather than just an ordinary single board computer? And finally, I will touch upon some upcoming exciting and innovative products in the iTech SWaP-C roadmap. Let's start by looking at the future battlefield. How will it change in 5-10 years? The current military market trends clearly indicate a heavy focus on automation. Less human soldiers on the battlefield, more smart equipment, which is either fully automated or remotely controlled. These types of unmanned aerial or ground vehicles can be used both for reconnaissance and combat. Unmanned aerial vehicles or UAVs are already ruling the air. They come in all shapes and sizes, from large combat UAVs like the US Air Force MQ-9 Reaper, responsible for taking down terrorists in distant areas, or tiny drones that can be launched by soldiers in the field or even in urban combat zones to scout for exact enemy locations. Closely following the UAVs developments are UGVs or unmanned ground vehicles. This can be used for ground strikes or for transport of heavy equipment through dangerous war zones. In some cases, a UGV may even carry a small aerial drone and launch it on demand in a remote area. Removing the need to host a human pilot or driver not only saves lives, but also allows to greatly shrink the size and weight of these unmanned vehicles, which in turn improves their abilities in the field and reduces costs. Such unmanned vehicles require sophisticated high-resolution cameras, radars, and other sensors, as well as high-performance computing capabilities combined with artificial intelligence to process data from all the sources in real time in order to react quickly to various external conditions and threats. And all of this must be implemented in a relatively small and lightweight package. So, other pillars of the future battlefield are smart soldiers and military robots. For human soldiers, special wearable equipment will provide augmented reality capabilities to be able, for example, to quickly distinguish friend from foe, and smart sensors that are able to detect an ambush or improve the soldier's aim in situations with limited visibility. It will also help the remote command center to keep better check on all soldier locations and threats in real time, and improve their tactics as battle progresses. Future military robots may serve as soldier companions to carry heavy equipment or clear the way in hard-to-pass areas. Obviously, implementing smart soldier equipment and field robots will require even further shrink in weight and size of the processing hardware, while still requiring advanced computing capabilities. Finally, all these various automated players on the future battlefield must be coordinated through effective communications and automated coordination protocols. So, for example, a drone picking up an enemy activity in a hidden spot will automatically warn the nearby squad of possible ambush. In a joint land-aerial strike, the command center can quickly select the most effective way to attack each target in real time, be it an unmanned tank, a UAV, or a nearby human soldier. Such automated coordination system from Rafael in Israel called FireViewer is already able to shorten the time required to complete an attack and destroy the target by 3 times. So what is SWaP-C and how is it related to the future battlefield? SWaP-C is not a new term. It's getting increasingly important as the size of military equipment keeps shrinking. As I mentioned on the previous slide, unmanned vehicles, military robots, and smart soldier equipment are all becoming increasingly limited in size and weight. So SWaP-C stands for size, weight, power, and cost, and is usually mentioned in the context of optimization of all these parameters or some of them. Size is the most straightforward one. Obviously, if you're building a small aerial drone, you cannot afford to use a rugged computer from a traditional military aircraft like F-16, as that computer itself may be the size of the whole drone. Weight is also very important, especially for UAVs, but also for ground vehicles in order to increase speed and agility or maneuverability. Of course, limiting the size of a rugged computer will usually also lower its weight, but this also may depend on the specific materials used. Power consumption is another important factor, which affects all others as well. Lowering the power consumption of computing and processing elements of a system helps reduce the size and weight of power supplies and cooling elements, which in turn also reduce both the equipment cost and the energy costs. And the defense market is becoming increasingly cost-aware. In this new reality of Covid-19, defense budgets are more limited than in the past, while the military is required to do more and more with less money and resources. Also, while the field equipment and unmanned vehicles are becoming smaller, their numbers are growing accordingly, which means the total cost of ownership of each individual piece of equipment, which is, for example, a small drone, must be much less than of a large drone or unmanned aircraft. All these parameters, size, weight, power, and cost, affect each other and must be carefully taken into consideration all together and each one individually when designing products for this new era of automated and highly effective defense systems. So while thinking about SWaP-C optimization, people usually envision small form factor systems or shrinking of existing equipment to smaller size and weight or smaller overall SWaP-C. This is what I call the same for less approach. This approach works well for small drones and variable soldier equipment, as there is no other choice there. In other cases, however, in large drones or airborne targeting pods, such as the one shown on the bottom left, there may be more room, even to host a full SWaPC system. In that case, however, the approach may be to integrate much more value-added functionality into the same size system, without increasing the overall SWaP-C. This is what I call the more for same approach. The trade-off between having much more functionality and performance in the same form factor or having the same or sometimes more as the technology progresses functionality and performance in a much smaller form factor will always depend on the target application. In any case, both approaches are valid and required to build a full product portfolio with SWaP-C in mind. And that is why at iTech we have a wide product portfolio covering both of these scenarios and are constantly improving and advancing our products in both of these categories. This slide shows some examples of exciting iTech products adhering to both SWaP-C optimization approaches. On the left, you can see SWaPC boards and systems under the more for same approach. These boards and systems pack a lot of value-added functionality, performance, and security enhancements through various hardware and software add-ons. I will touch upon this in more detail in the following slides. The SWaPC systems such as the A19X series are extremely flexible, modular, and customizable. They may host a variety of functions within the same enclosure, for example, one or more high-end SBCs, advanced DP-GPU boards, switch and I/O extension boards, all packed into the same SWaPC chassis. On the right, under the same for less umbrella, you can see various small form factor systems. They have specific, fixed, dedicated functions such as small rugged Intel architecture computer, a standalone internet switch or router, and a remote I/O extension unit. We are already working on significant improvements in both of these portfolio sectors. On one hand, to pack even more functionality and performance into the SWaPC boards and systems, while on the other hand, to further reduce SWaP-C of the small form factor systems. And at the same time, make them more flexible and extensible. If you're interested in more information on details on any of these products, you're welcome to visit our website after this presentation or contact iTech Sales. Here I would like to talk about my long-term vision for the two sides of the SWaP-C coin, focusing on single-board computers and standalone ranked computers. On the slide, you can see a comparison between the different aspects and parameters of each type of products. And as you can see, there are some similarities, but also major differences between the two. For example, on the right side, we are looking at much more power-efficient CPUs with up to 4 cores today, possibly growing to 8 cores in the future, while on the left side, for most performance-demanding applications, it's possible to grow up to 16 cores with high-end embedded processors like Intel Xeon D, and in the future, possibly even 32 cores using power-efficient ARM architecture. We are definitely looking into both Intel and ARM in the long term, although our focus in the 2021 roadmap is the next generation of Intel processors. So for more for same approach, we are talking mainly about SWaPC boards and systems. High-end processors and various add-on hardware and software functions embedded into the same SWaPC board, as we will see on the next slide. In case you haven't heard yet, iTech is now a member of both SOSA and FACE consortiums, as we are committed to full alignment with these industry standards for bringing more innovation and interoperability into the market and to our customers. This slide shows the concept of iTech flagship SWaPC SBCs, of what I like to call more than a computer. This means that our specialty, as part of the more for same approach, is to pack much more functionality and performance than just an Intel processor into the same relatively small SWaPC form factor. Besides having a high-end embedded Intel CPU with up to 16 cores, these SBCs provide large RAM and storage capacity. One of the main attractions is the large onboard Xilinx FPGA, which allows the offloading of heavy processing function from the CPU, or enhancing the system security. Having this FPGA on board means there is no need to buy an additional FPGA board, which in turn reduces both size, weight, and cost of the system. We will touch more on the onboard FPGA possibilities in a minute. Speaking about security, iTech flagship SBCs feature an advanced iSecure cybersecurity framework, which was covered in the previous presentation by our VP of R&D, Boris Bayer. High-speed connectivity, currently supporting up to 8x or 16x PCI Express Gen 3, depending on specific SBC, and up to 40 gigabit Ethernet, allows fast connection to GPGPUs, high-resolution Gigi vision cameras, and other high-bandwidth sensor I/O. If the onboard functionality is not enough, XMC and M2 sites, depending on the specific SBC, allow adding functionality within the same SWaPC form factor without using an additional slot. iTech offers a variety of innovative XMC products, such as a fully managed Ethernet switch router on XMC, so it's possible to build a subsystem, what I call smart sandwich, of SBC, Ethernet and Ethernet switch using only a single SWaPC slot. M2 slots allow adding secure storage as well as special I/O like CAN bus, or in the future FPGAs and dedicated AI acceleration based on the Intel Movidius visual processing units, all in a very space-efficient form factors. With support for various software add-ons like Health monitoring, and Dolphin PCI Express connectivity framework, our customers can really do a lot with this relatively small SWaPC board. So on the following slides, we will look a bit deeper into some of the aspects of the more than a computer approach. First, let's discuss the value of having a large onboard FPGA. FPGAs can be used to offload heavy workloads from the CPU, for example, data encryption or signal processing tasks. Having such FPGA on board saves system footprint and power budget, as well as costs. FPGAs are going through an immense evolution process during the last several years. Besides the ever-increasing logic and memory densities, they provide internal CPU ARM cores, making a true system on a chip. These internal CPU cores allow also offloading of FPGA control functions from the main CPU. Specialized integrated hardware functions like analog RF I/O and processing are now also part of the innovative FPGA SoCs within the Xilinx RF SoC product line. And these functions are fundamental for some military applications like radars. Xilinx next generation FPGAs, which they now call ACAP, Adaptive Compute Acceleration Platforms, will also include specialized and highly parallel artificial intelligence acceleration and DSP engines, in addition to the ARM Cortex A72 CPU cores and traditional programmable logic. All in all, having an advanced FPGA SoC on board and SBC significantly increase the capabilities, capacity, and performance without increasing the overall footprint. However, integrating such FPGA onto a SWaPC board is not an easy feat, and it greatly complicates board design and layout. iTech has proven this capability with our existing C877 and C878 products, which include an onboard Xilinx Zinc UltraScale MP SoC without compromising the other high-end features of the SBC. As I already mentioned, our next generation flagship SBCs will also feature even more sophisticated onboard FPGAs, such as RF SoC or the next generation adaptive compute acceleration platforms. Let's talk about iSecure. Thanks, Boris, for the detailed presentation explaining all aspects of our advanced cybersecurity framework. I'd like to take it a bit higher and talk about the main value to our customers. What iSecure really provides is increased survivability and level of confidence in the field, with much lower chances of a cyber attack during an actual deployment or maintenance of the system where the iTech SBC has been installed. With the defense market adopting more and more advanced technologies from the civil market, these technologies also bring with them more potential cybersecurity issues and holes. So having a secure solution on the battlefield is becoming increasingly important. not only to protect human lives during an actual battle, but also to protect sensitive or confidential data from being compromised, stolen, or modified for malicious purposes. That's why iSecure protects the SBC itself in terms of hardware, firmware, software, as well as data being stored on it on multiple levels. In addition, some of the aspects of iSecure provide protection from reverse engineering and cloning of firmware and software, which makes the system safer for export to allies. Some words on software. Our goal at iTech is to increasingly provide more and better value to our customers. And part of this will be done by putting more focus on an investment in software add-ons and solutions going forward. Here are some examples of add-on software modules we are planning to develop during 2021. iHealth is iTech integrated health monitoring solution, which provides a common health monitoring API across our platforms and allows collecting health status from various hardware components, predicting failures, and performing online system performance monitoring. We are going to integrate the PCI Express Fabric communication library from Dolphin Integrated Solutions. This library supports high-speed, low-latency peer-to-peer communication between PCI Express devices. It simplifies customer application development and shortens time to market by hiding the complexities and technical details of programming PCI Express devices directly. And finally, as part of our commitment to new interoperable standards, we are going to provide operating system and board support packages options with phase conformance based on WinDriver Linux and VxWorks 653. Here are some examples of how SBC functionality can be further extended through XMC mezzanines. XMC provides a way to add significant capabilities within the footprint of a single 3VPX slot. Some of our most innovative XMC products are managed Ethernet switches like the M620 and the M640, which support Ethernet speeds up to 1 gigabit Ethernet and up to 16 ports on the M620, the fully managed Ethernet switch router on XMC. This creates a very efficient combination of XMC and switch in a single 3VPX slot. The next generation of Ethernet switching technology will support 10 GigE and 40 GigE interfaces and advancing further to 100 GigE based on 25 Gbps SerDes lanes with fully featured Layer 2 and Layer 3 networking capabilities and very fast boot times. In addition, we are working on new graphics and I/O extension XMCs as shown on this slide. Now, let's explore the other side of the SWaP-C coin, the same for less approach. Here, as you can see, the main focus is on minimizing the form factor and power consumption and not on performance or integration of multiple functions, although some minimal degree of performance and capacity is still required. And CPU vendors like Intel are able to significantly increase computing performance and add more functionality within the same power envelope, as you will see on the next slide. Some of the products in this category, especially those based on PowerPC architecture, are also DO254 and DO178 certifiable for flight safety critical applications. One of the newest exciting products, which is very relevant to SWaP-C optimization, is the Intel Tiger Lake UP3 system on chip. This system on chip provides a powerful CPU and a powerful integrated GPU alongside inherent artificial intelligence acceleration instructions, powerful video processing, and security enhancements. All this while keeping the overall power consumption at low-medium level of either 15 watts or 28 watts, depending on the CPU frequency. And the CPU is based on Intel 11th generation core with up to 4 cores and 8 threads, and around 20% increase in single-thread performance versus the previous generation. On top of the pure CPU performance, further improvements are gained through the increased memory bandwidth. The GPU is the Intel 12th generation GPU technology with 96 execution units. According to initial benchmark, this GPU is powerful enough to deliver similar performance to some NVIDIA discrete GPUs, so for some applications, this integrated GPU can replace the external GPU, saving both space, power, and cost. This CPU also provides new cybersecurity capabilities for better protection of keys and memory contents, as well as protection against flow control-based attacks. These new capabilities will be fully integrated into the iSecure framework. And due to its small size and limited power envelope, while still providing an excellent performance balance between the scalar, that is CPU, and the parallel, that is GPU processing capabilities, this system on chip is perfect for next generation of SWaP-C optimized solutions. And iTech is now working on 2 exciting next generation products based on the Intel Tiger Lake UP3 CPU SoC a SWaPC SBC and a modular rugged mini computer. C850 is a SWaPC SBC providing an excellent balance of CPU and GPU performance versus power and costs. It features 32 GB of RAM and up to 2 TB of M2 storage. It also features additional M2 and XMC sites for further extensions, as well as our advanced cybersecurity frameworks, which we already covered. The A181 is an innovative small form factor concept for small unmanned vehicles and robotics that we are designing around the Intel Tiger Lake UP3 SoC. It's a modular rugged mini computer. It will be available as a standalone miniature base unit featuring a fully functional computer with Intel architecture CPU, integrated GPU and artificial intelligence acceleration capabilities. This provides a balanced combination of both the powerful CPU and the GPU with basic I/O like Ethernet and USB. However, in addition to the base unit, various extension modules will be available providing either I/O extensions for avionics, such as 1553B or RING428, additional AI acceleration where higher GPU performance is required, or FPGA, which can be used for example offloading of digital processing function or additional security enhancements. Finally, a couple of words about our small form factor switches. This includes the currently available A664, which supports up to 16 1 gigabit Ethernet ports, with 4 of them being fiber optical ports. And fiber optics enable applications where copper cable link distance, bandwidths, or physical characteristics are unacceptable. And the A664 is a fully managed switch router supporting a variety of layer 2 and layer 3 networking capabilities alongside security enhancements and fast boot mode. It's SWaP-C optimized, weighing less than 2.5 kilograms, with power consumption limited to 25 watts. And the next generation switch in this series, the A665, is currently under development and will feature 10 gigabit Ethernet, 40 gigabit Ethernet, and even one or more 100 gigabit Ethernet optical interfaces within a much smaller enclosure. Thank you for watching. I hope you enjoyed this presentation. We covered a lot of material and my intention was to provide an overview of concepts and technologies as well as existing and future iTech products aimed at solving the SWaP-C optimization challenges of the future battlefield. If you have any questions on this or other related topics or would like to get more information and details about the products I presented, feel free to contact us through the website or the sales channels, or email me directly at the address shown on the slide. Have a good day, stay safe and healthy.